Hello and welcome to our next subtopic. We are still continuing with the physics topic, pressure in book 1. We have looked at pressure, we have looked at pressure in fluids and in solids. We have seen the concept of atmospheric pressure, and now we are going to look at the applications of atmospheric pressure. To state them generally, we dealt with applications of the principle of transmission of pressure, and under that we saw the hydraulic machines, whereby we add the hydraulic brake system. We also saw the hydraulic lift and press, which work the same concepts. Now, under the atmospheric pressure, the applications are several. We are going to see the drinking straw. The drinking straw, it applies the principle under atmospheric pressure. In the same concept, we are going to see how the bicycle pump works. The bicycle pump. We are also going to see the syringe. We are also going to see the siphon. We also have the lift pump and the force pump, all working under the same principle. So all this is under atmospheric pressure, but the first two applications are under the Pascal's principle. Let me start explaining these things with the drinking straw. I know it is not a new phenomenon. Most of us have seen or else have used the drinking straw. We have used it to take in several beverages like sodas, porridge, and other things. Now, this is what happens while we're using the drinking straw. You find that your liquid is here. You can say your soda. We use it as an example. We have soda here. Then now a straw is dipped in. A straw is dipped in to the soda. It is good to realize that when the straw is dipped in the soda, nothing happens. We don't see the soda racing up the straw. But when someone sucks in, the soda pumps and it is able to be drunk. Now, this is what happens now. Initially, when you have not sucked through the straw, initially, the atmospheric pressure balances. The atmospheric pressure balances in the container here and also in the straw. So you find, because the straw is open, then atmospheric pressure is acting on the surface of the liquid, and also it is acting through that opening of the straw. And therefore, because of that, then you find pressure is balanced, both outside the straw and inside the straw. Pressure is balanced because it is acting everywhere. But now this is what happens. Once you suck out, this is now the main point. Once you suck out the air, which is in the straw, which is in the straw, the pressure inside the straw goes down or is reduced. Therefore, you find now the pressure which is outside is due to atmosphere, and the pressure which is inside the straw is also due to atmosphere. But when you suck now, when you come and suck now, this is your mouth now. When you suck the air column which is in the straw, it means now inside the straw there is no air column now. It is a vacuum, a free space. And now because you have reduced the air which is here, it means pressure reduces. Pressure reduces. Therefore, when you suck the air which is inside the straw now, pressure inside the straw goes down now. Then now, because the pressure has reduced there, we can say now the atmospheric pressure outside the straw pushes up the liquid. Pushes up the liquid, and the one is able to drink. So you find now, because atmospheric pressure now is greater than the pressure which is inside the straw now, because you have reduced or you have removed the air which is causing pressure inside the straw, then inside the straw it becomes a low pressure zone. And now because atmospheric pressure outside the straw is now greater, it pumps up the liquid through the straw to your mouth. And that's how the concept is simply applied. I would like to discuss also the bicycle pump before we check something else. The bicycle pump is a machine which applies atmospheric pressure in its operation. Allow me first of all draw the pump. I know we've seen it in several occasions. We know what a bicycle pump is. Bicycles are not very rare means of transport that we use them regularly. Therefore, the bicycle pump, you have seen it in some occasions, and the one is here on the board. So, I will show you how the principle of atmospheric pressure applies in the operation of a bicycle pump. In the operation of a bicycle pump. So what we have here is a spring. This is a spring. This is the handle. Then this is called a leather washer. This is a leather washer. Then apart from the leather washer, we have this container here called the barrel. Then with that now, I'll move to explaining how this machine works, the bicycle pump. The bicycle pump. So what happens under the bicycle pump? I would like first of all to give you a very sensitive note here. Before we continue, it's good to note that this machine applies something called, though it is in book 2, I know we are studying from one work, but there is something in book 3 which is very key for the operation of this machine. And we are saying that the thing is Boyle's law. Boyle's law of gas. Under gas laws, we have Boyle's law, which says that pressure is inversely proportional to volume. So volume and the pressure are inversely proportional variables. Therefore, when you increase volume of a given air, then you reduce its pressure. And on the contrary, when you reduce volume, pressure goes up. So this is what happens. You find when the pump is settled, pressure outside, which is atmospheric, balances the pressure which is inside the barrel. And therefore you find we have a leather washer which is flexible. Therefore you can say when the flexible leather washer is pushed in to the barrel, of course, into the barrel, when we push using the handle, you push the flexible leather washer inside, you find that the volume of the air reduces, and hence the pressure is increased, because the volume of this barrel, you are reducing it by pushing the leather inside. You find that the air here is being squeezed into a smaller volume, and by such doing, the pressure is increased. Once the pressure is increased, you find now this is a valve which goes to the tube. So you find now the pressure, because it has increased now, then the pressure inside the tube, now the high pressure pushes air into the tube through the valve. Therefore, we have a valve here which now opens to allow the air into the tube, because the leather washer has been pushed in, squeezing the volume into a smaller volume. And we have said, according to Boyle's law, when volume is reduced, pressure increases, and vice versa. Therefore now the increased pressure now makes air to be pushed through the valve into the tube of the bicycle. Again, now in the reverse process let me mention what happens in the reverse process. When the leather washer, which is flexible, is pulled out, when it's pulled out, the volume in the barrel is increased, and hence the pressure reduces. Therefore, this is what we are saying. When you push out the leather washer, you are increasing the volume in the barrel. And once volume is increased, we have said that because volume is inversely proportional to pressure, then the pressure goes down. So we find that now inside the barrel, a low pressure zone has been created. And thus, you find now the pressure in the barrel is not balanced with the pressure in the atmosphere, because the pressure in the atmosphere is now greater. Therefore, we can say now, the greater atmospheric pressure outside pushes air into the barrel. Therefore, you find now, once you pull out, volume increases, pressure reduces. Atmospheric pressure becomes greater. And therefore now, it is able, because it is greater outside, it is able to pump in air through the walls against the flexible leather washer. Air comes in. So we have air which comes in now, once you pull out. And once air has entered, you apply again a forward stroke, whereby you again reduce the volume, increasing pressure, making now the air again go further through the valve into the tube. And the process repeats itself until the tube is inflated enough. And that's how the bicycle pump works. I would like us to check the other applications, which is a syringe. The third application under this is a syringe. A syringe is not very different from the bicycle pump. I know we have also seen syringes. The third one, the syringe. Whether in the hospital or in the farms, we have syringes in use, and they all apply the same concept. We know how a syringe looks like. We have the handle, then we got a piston here, we got a piston here, then we have this other part now. So we can have a needle now connected here, like that. Therefore, you find that you have a liquid here, the liquid medicine you want to inject. This is a liquid medicine, and just call it a liquid like that. Therefore, you find this is also a barrel. It's a barrel like the one for the bicycle pump. This is the handle. There's a piston. There's a needle. Therefore, now for the syringe to function, we apply again Boyle's law. So Boyle's law is very key under the applications of atmospheric pressure. Therefore, you find what happens is that once the doctor pushes in this handle, you find that this liquid is squeezed into a small volume. And therefore, once it has been pushed into a small volume, its pressure increases. Once its pressure increases, it means the pressure now has become greater than the blood pressure. So if this is the person, if this is the person's hand, which we want to inject, now you find the pressure in this liquid medicine here has increased higher than the blood pressure. And therefore, once you press inside, you find that the pressure increases greater than the blood pressure in the bloodstream of this human being. And now, because this pressure is greater, the liquid medicine is pumped into the bloodstream of this person. Then, after now, he has been injected, you can now pull out this one now. Once you pull out now, you find now pressure here, the volume increases, pressure goes down, and the medicine stops going into the bloodstream. Therefore, this is what happens. When the handle is pushed in, we are saying the volume in which the medicine is. The volume decreases, thus increasing in pressure. Because volume has decreased, pressure increases. That's why you find now the greater pressure now. The greater pressure makes the liquid medicine to flow into the blood. The bloodstream, you can call it bloodstream, which is at a lower pressure. Therefore, that is what happens. All these machines are applying almost the same principle. We have the lift pump, which applies the same principle. We have the force pump, which applies the same principle. And we also have the siphon system, which applies the same principle. Therefore, that's all about pressure. I can be receiving a few questions under the comments. Please, if you have a question, place it under the comments. We are going to help you. Make sure you subscribe to our channel. Thank you for listening to us. God bless you.